Hello and welcome to another episode of Cloud with Chris. You're with me, Chris Reddington, and we will be talking about all things cloud. And you'll probably notice in this session we've actually got no video from myself. Unfortunately, we've been having some technical issues, but we wanted to go ahead, still run the session. We're able to do screen shares, but the videos are a little bit jittery, so didn't want to distract away from the content for you all today. So we'll carry on as planned, and we'll go ahead and get looking at some patterns today. So you know the deal. If the content is useful, please do go ahead, please like, please subscribe, and please go and share on with other people who you think might like this as well, because we want to make sure that this content is getting out there and really being used by people, because that's exactly why we're doing this. So on to today's session then. We're continuing with the architecting in the cloud one pattern at a time concept, and I am delighted today to be talking about another set of patterns with yet another great colleague from my team. So at this point it's probably best for me to introduce Steph. Hey Steph, how are you doing?
Yes, I'm good, thank you.
Good. Glad to have you on the show. So I guess it's probably best for us to start with a bit around yourself and your background, if you want to start there.
Sure, yeah. So I was thinking about this just the other day, and do you realise it's probably just over 2 years ago that you interviewed me for my role in Fast Track?
It hasn't been that long. Wow. That has really flown by. I remember. It feels like yesterday. It really does feel like yesterday.
It
Wow.
does. And at the time, of course, I joined your team, and we were a UK-based team.
Yeah.
And now we've gone our separate ways, as it were. And I'm now sitting in the data team, because that's about where my background is and where all my history is with SQL development and business intelligence, data warehousing. And all that kind of interesting data related area.
Excellent. And wow, you're making me reminisce. Geez, 2 years has absolutely flown by, hasn't it?
It has.
Wow.
Yeah.
Wow. Excellent. So good. I guess you've given us a little hint there as well about the background on the data side, and SQL is kind of where your background is, and I think the patterns that we're going to be talking about today are very relevant for that. So we're going to be talking about two particular patterns today. So sharding, and I think it was the index table pattern, wasn't it? We were going to talk about here as well. So I guess the elephant in the room is probably what we should address first, which is sharding is this word that has been around for such a long time. For data people, they're probably maybe rolling their eyes listening as we're talking here and thinking, okay, yeah, we know sharding, what's new? And I think that's really the point of this, isn't it? Is some of these patterns aren't new and they're still relevant when we start going into the cloud.
Absolutely. Yeah. I mean, sharding has been around for a while. It's always been something that you could do. But typically it wasn't done. So in traditional on-premises SQL Server world, the answer to running out of resources on your server was to just throw more resources at it, whether that was storage or memory or compute. And that's true to an extent in the cloud as well. So Azure SQL Database gives you an amazing ability to scale up as your workload grows, so you can start small. So it's that kind of vertical scaling we're still seeing. But what sharding is really is horizontal scaling, and that would have been harder on premises because you would have had to have bought another server, so another set of hardware and that sort of thing. So although sharding, you might also hear that being called scaling out, horizontal scaling, was an option. It wasn't an option for a lot of people because of the nature of finding space in your server room for yet more hardware.
Gotcha. And I guess that's the point here, isn't it? Is that the pattern itself isn't new, but the fact that the way cloud is kind of built and the way that cloud works is that we're able to go and use this pattern more often, really, because we don't have those same restrictions in terms of space, in terms of the amount of servers, for example, and machines that we have access to. We can go ahead and think bigger. So now those boundaries are a little bit different, and we see this pattern being used a little bit more here.
Absolutely, and we see it quite a lot in the SaaS, the software as a service world. So I worked with in my previous life as an on-prem SQL developer, I worked with customers, and every customer had their own database. What we very quickly found was that we just had several different versions of the same thing.
Right.
And so everybody then ended up with a bespoke copy of the database. And before you knew it, you were trying to maintain umpteen different copies. With the cloud, with sharding, and especially with Azure SQL Database, with its built-in Elastic Client Library, you're able to maintain the same schema across multiple tenants. And that's been really, really useful for our customers, so that they can separate their customers' data out onto different databases. And that might be because of data sovereignty regulations, or just size. And you get away from the noisy neighbor. So I've got one customer who's got a huge amount of data and a huge amount of processing going on, lots of queries happening, and other customers who are struggling to get the resource because they're smaller, and then they're complaining about performance. So in Azure SQL Database, using the Elastic Client Library, it gives you the ability to really separate those customers out onto their own workload with their own resources, but manage the whole thing as a single entity. So you haven't got that maintenance nightmare of maintaining tens or hundreds of different databases.
Understood. And I think you read my mind. I was going to probe into, where are the reasons, or what are the potential scenarios where we might actually want to go and shard. So it sounds like whether it's maybe something to do with resource constraints, and we've got, different, let's say we've got a SaaS platform, software as a service, and we've got different users, but one's particularly noisy and hogging all of the resources. Maybe we want to separate those out into different shard, for example. Maybe we want to do that for some kind of compliance reason. Maybe even sharding across regions is something that we sometimes see as well, don't we, in terms of geographical boundaries of where the data is stored as well. So those are probably a good couple of indicators that sharding might be an approach you want to take if you're thinking of these kinds of challenges for your solution there.
Absolutely, and the regional one is a good point, actually, because that would have been harder on premises to do that. The latency between physical on-premises data centers typically was too high to really do anything with, and yet we're seeing an increasing number of countries, people and citizens, governments and citizens, saying, no, we don't want our data to live outside of our region. And that's a lot easier now to do that with cloud than it ever was doing that on premises.
Gotcha. And I think the key point as well, before we start talking about how you might actually go and use sharding a bit more, is just to really re-emphasize the fact that whilst you can go and kind of scale up your instances, so like if we stick with the SQL analogies there, your Azure SQL databases, you can scale those up, but there might still be a point where actually you do need to shard because you're going to start hitting some limits. So even though some of those problems go away with the nature of cloud and kind of building upwards, we still will need to consider probably at some point this pattern of using sharding and being able to actually go and use these multiple databases as well, as you say here.
Yeah, so and to that point, actually, so even in Azure, even if you can scale up all of your resources, and all of our resources will scale to an extent, there is a limit. There is still going to be a hard limit. For SQL database, that's the number of vCores and the amount of storage you can have. For things like Cosmos DB, there's a limit on the number of request units you can have. So at some point, you are going to hit that upper limit of your vertical scale. It's not an endless process.
Gotcha. So then, I guess if I'm listening in and I'm maybe not someone with a data background, and I'm thinking, okay, this whole sharding pattern sounds like it might be relevant to me, but where do I start with that? What are maybe some of the things that I need to start thinking about on how I break up either those databases or the data itself to start using this sharding pattern?
So the key thing really is, and it goes back to basics, the requirements. So do you have regulations that you need to adhere to? Do you have specific performance targets that you have to meet? What are your queries doing? Are you a multi-tenant scenario? So are you looking at software as a service, or are you just looking to break out certain members of your team that are querying? So do you need to really, you need to look at the queries, you need to look at your data, and you need to understand what it is that the business needs to achieve
So
from
it's
the
not
data
just enough.
posted to your database.
Gotcha. So it's not just enough then to go and say, right, we're going to go split up the databases and now we're done, we've sharded. We need to understand, maybe what some of those access patterns are, how we're separating the data, because I guess if we do it the wrong way, there's potentially going to be some detrimental effects of actually doing that then as well.
Yeah, so we'd call that cross shard query. And that's always going to be a performance problem, and especially if your shards are in different regions, for example.
Gotcha.
So there are kind of several strategies that you can have. So again, depending on how you want to break up your data, if you were a software as a service and you wanted to break up your data based on your customer, then customer ID would be a good shard key. Because you're not typically going to query across customers. You're only ever going to want customer data to be queried within its own context. So the number of sales that customers have. And more importantly, they're only going to want to query that. They're not going to want to query other customers' data. So if you're in that situation, then some kind of a lookup on a customer ID is really important. Now, what that does mean is you're probably going to need to put that customer ID on all of your tables so that any query that you run knows exactly which shard to go to. The other thing that you might want to think about is grouping your data on ranges. So if you're talking about a financial reporting system, for example, and you want to be able to query everything that's happened this month, or you want to get all of your summary data for last month, being able to query just the data within that shard will make that query more efficient than if the data is spread across multiple shards. And we see this a lot with things like financial services. There's a requirement to keep a number of years worth of data. And there may be comparisons of month on month. So you might pull out the data from two shards and compare them year on year. So, it is kind of cross shard, but you're not searching in lots of shards and joining across. So ranges can work if you're looking at that kind of range of data by a month, and you can use it by region as well. So if you wanted to know what are the sales for customers in the US, you might have a shard that's just got your US customers in it. And we're talking, say, in a retail scenario rather than a multi-tenant scenario then.
Sure.
Think of VentureWorks. I had to get that in. I'm a data person. Everybody loves a VentureWorks.
Exactly.
So grouping on region or splitting by region might be a good one. And then if you really don't know what you're going to shard on, and you just want to balance the data, then hashing a key can help reduce hotspots. Again, it really depends, where is your performance hit happening? Is it noisy neighbor? Do you need to be able to keep one person separate from everybody else? Or is it just the fact that you need to be able to scale individual resources vertically? Because you can scale these shards vertically as well if you need to. Yeah, always back to the requirements, back to what data is being used for.
Absolutely. And I love it when guests come on and start talking about requirements, because it means that I don't have to do that. It means someone else has plugged it, and I completely agree. It all starts there, absolutely. And as you were explaining that, I was thinking of some of the similarities between like Cosmos DB, where it's just as important to have think about the partitioning key that you're using because of throughput and performance, and not doing cross query kind of cross partition queries. It's kind of a similar idea there by the sounds of it. So
It is
yeah,
very similar.
good, good. Okay, that makes sense. So then, I guess that's the maybe some example scenarios of when we would go and shard, and we talked about maybe some of the strategies and keys that we would go and use. What are maybe some of the things then we would want to think about next? Maybe some of the issues with it, for example, challenges that might arise in that type of scenario, for example.
Sure, yeah. So I guess it depends on how you've split the data, what your criteria was for doing it. Keeping your shards balanced is a challenge. If you're in a scenario where you're just really wanting to spread the data evenly across the shards, you might find that you have specific hotspots on a particular shard, and that might come down to, again, going back and looking at, was that the right key to be sharding on? And that's where using a hash value can be a good compromise. If you need to add more shards, then you want to think about, how do I rebalance the data that I've already got? So in a software as a service scenario, if you're using a single tenant approach where you have one shard per customer, then that's probably fine, and you can scale those shards up individually as and when you need to. If you're in a multi-tenant environment, so shard 1 has got customer 1, 2 and 3 on it, what happens when you add more customers, or what happens when one of those customers gets excessively large? So say customer 2 has suddenly grown massively, you probably want to take that out and put it on its own shard, because otherwise you've still got the same noisy neighbor problem that you had before you started. So then you have to think about, how do I rebalance my shards so that I get the right customers in the right place?
Gotcha. Okay, so I guess if we're in an environment that is potentially growing quite a lot, let's say, and we're sharding based upon a key which is related to that growth, like a customer ID, having some forward planning and forward thought in terms of how we're going to manage that is really important, is what I'm hearing there. Okay,
Yeah,
that makes
yeah,
sense.
absolutely.
That makes sense. Okay, and I guess then there's maybe not to cover it in this session, but there's probably approaches as well where I think you mentioned earlier, we might have a scenario where we care about understanding from a management perspective. We've got a multi-tenant environment, we've got different customers, we've sharded based upon the customer ID. From a management perspective, we might care how many end users are using the system across all our customer base. We might care about how many active users we've got, these kind of things.
Yeah, absolutely. Those metrics
yeah.
are going to be available on a database by database level. So yeah, you can see the activity spread across the databases. If you had all of your customers in one database, it's really hard actually to know who's using all your resources. You can see what the queries are, but you don't necessarily know. You're not necessarily able to tie that back to specific users or specific customers.
Yeah, indeed. That's interesting. And I guess if we think even like from the business perspective, then in terms of our actual end users using the system, let's say that Contoso has 100 active users. AdventureWorks, we'll throw it in again, has 100 users. Maybe we care about the fact from a business perspective, knowing we've got like 110 end users actually using the system. And there are probably patterns that we can like materialize those views as well, I guess, across the different shards and bring that data together with, whether it's looking at our wider pipeline of data activities that are happening. But I guess the point here is don't necessarily rely on the cross query approach, because that's not necessarily going to give you great performance if you're looking to do regular tasks in that kind of way. It's kind of what we're saying, isn't it?
Yeah, and there are other ways to get that kind of data. If you were looking at doing a management view or a business view over what's happening with the databases, there are probably other ways of getting that data rather than just doing a cross-shard query to get that information.
Gotcha. Good. So we've talked then, I guess, about balancing the shards. We've talked about the shard keys and making sure that we're using, I guess, stable data to actually go and use that. We've talked about potentially using things like hash keys or hashes of keys as well, querying the shard and not across shards. Are there other kind of things? It seems like there's quite a few different considerations when we actually get into the deep parts of it here.
There are. So there are some implications for your application as well. So if you're going to use a customer ID, for example, as a key, then in order for you to get the data out of the shard, you need to know which shard you've got to query. So potentially your application has to now make two calls. So one to a location to get the shard key, and one to actually get the data from the shard itself. So that could have performance implications for you in terms of your application speed. Azure SQL Database has something called a shard map manager that allows you to configure everything, and you can connect to that to get your shard keys and your shard IDs out. So so primarily there's the complexity, but there are also implications, as I said, for the application, and it's extra maintenance. So it's people have to understand how it works. So even the developer, who might be a .NET developer, might not be a full stack developer, might not necessarily know anything about SQL, is going to have to deal with this shard mapping in order to get the data. So that might be something that's tricky for some of our customers, where they have smaller teams.
In some way, it's going to impact that application design and potentially the API design is kind of what I'm hearing there. So makes sense. And I guess you mentioned there about the shard map manager, I think, with Azure SQL DB. But I guess I'm hearing almost similarities to a degree, and maybe I'm stretching the analogy loosely here, but stay with me, around another pattern, which is the index table pattern then as well, in terms of, keeping track of what data is where, and then having an index that you're going to go manage. So then you've got that, you've got a pointer effectively, right, is what we're talking about here. So have I understood rightly, or am I completely way off the mark, do you think?
So the index pattern's interesting because that's not for relational databases.
Okay.
I'll just reshare my screen with the index pattern.
No worries. I've temporarily taken over on the broadcast and showing the index table as well, just in case.
Okay. Brilliant.
So no issues there.
Because I've got too many browsers open.
All good. No issues.
Okay, so we should be able to see that now.
Cool. I'll switch that back. There we go. Good. Yeah.
Yeah, so the index table pattern is slightly different. This is where we're talking about NoSQL, really. So with SQL and other relational data stores, we're quite used to being able to use a secondary index on our tables. So typically our customers might be stored by their customer ID, but I might not necessarily want to query on the customer ID. I might want to query on their location, for example, or the last date they made a sale, or whatever it is. And with a relational database, that's fine, because I can just create an index on their location, and that's a copy of the data stored on a different attribute, ordered however I want it to be ordered, that I can query directly, and that's going to speed up my queries. the NoSQL data stores don't have that typically. So there's not really a way of saying, actually, I want to query on the index. For efficient queries, not a way to query on a secondary index. For efficient queries, you need to know what the index key is.
Gotcha.
So yeah, slightly different.
Yeah, no, it makes complete sense. And I guess it's a nice segue because we were going to talk about this one anyway, the index table. So I've kind of forced us to go down this route now. So here we are. But it makes complete sense. Again, I'll bring the analogy back of something like Cosmos DB, where a pet project I've been working on, I've mentioned on the channel in the past, is like an inventory for Yu-Gi-Oh cards, and those cards might have a card ID, they might have a set number, they might have I don't know, some kind of categorization for those cards. So if for something in Cosmos DB, depending upon the access model, the access approach that I'm using, and the common querying patterns, we commonly hear with Cosmos DB, partitioning your data is important because of the being efficient, I guess, in terms of the request units you're going to use.
Yeah.
And this is where we'd have these kind of separate index table type patterns is what I'm seeing. And I guess, would we then say from a general kind of pattern perspective, that index table, then we'd commonly see that being used with the sharding pattern as well? Only with the sharding pattern? Are they kind of common pair, would you say? What are some of the things you've seen maybe in terms of this being used?
I think you do see them together. Primarily anything that you can do to help query performance on very large data sets, you're going to see multiple patterns being used together to try and address different issues. With Cosmos DB, you're right, and one of the key things is getting your partitioning key right, but typically you want to query on something else.
Yes.
So one of the options is to duplicate the data, which isn't something that we would necessarily do with sharding. So we're not duplicating the data with sharding. We are physically separating it. So there's a slight difference. You can combine the two together. So you could physically separate your data into different shards and then have secondary index or index tables applied over the top of that to further improve the performance once you're in the shard. Yeah, but with Cosmos DB, yeah, one of the patterns for the index table pattern, one of the options is to duplicate the data. So storing the same data but ordered on a different, or indexed on a different attribute.
Gotcha. And the nice thing about Cosmos DB in particular, compared to maybe some of the other data services with that particular scenario, is the fact if we update the data in one of our databases or containers, or whichever approach you're using based upon the terminology, but you can use something like the change feeds to go and update the relevant documents then in the other storage areas then as well, so you keep that consistency there. And I guess that's what would be the challenge potentially in some of these kind of sharding scenarios, is being able to make sure that data is consistent across those different areas, because that's why you wouldn't typically see that done in that sharding scenario there then, I guess.
Yeah, absolutely. You wouldn't want to shard based on that partition key and then have a different set of the data stored somewhere else and sharded differently, because I think that would just cause your application a huge overhead in querying. Gotcha. So shard first and then index table within your shard, so that you would store the same data within the shard but ordered differently.
Yeah,
rather than storing a different shard. Yeah.
Makes sense. So it's that reference to enable faster access within the data set rather than being used as a mapping across the different data sets is really what we're seeing. Got it.
Yeah.
Makes sense. Good. So I think that gives a good overview on the index table pattern there, Steph. So I guess conscious of our time here and kind of wrapping us up, but are there any last kind of parting thoughts you would give here in terms of either of these patterns, things to watch out for, things to be aware of, or anything that you just want to resurface from what we've chatted about here?
So I love both of these patterns. I think they're really, really valuable in a world where we have an increasing amount of data to take care of and to surface quicker than we've ever done it before. Everybody wants everything and they want it now. So we need to be able to find strategies to deal with that. I think the thing to just be wary of the index table pattern. So duplicating the data is fine, but we see in a relational database world, people will create an index, a secondary index to satisfy a specific query, and then someone else has a different query and they create another index and a different query that creates another index, and that's okay to a point. But what you have to be careful of, although storage is least expensive compared to compute, storing multiple copies of your data to satisfy individual queries is going to get expensive and is going to get complicated, and you're going to pay a big penalty on your write performance because you're going to have to replicate those writes across all of those duplicates. One of the patterns that I like with the index table is the I forget what they called it in here.
I think there's some of the patterns at the very bottom of the screen there as well. It might be down there.
Yeah, there was a specific word that we had for the index. A normalized index.
Yeah,
that's what I was looking for. The word escaped me. I really like that because you're storing a subset of the data as a duplicate, not the whole thing. And I've seen this work really, really, really well, where you've got very wide tables. So I worked on a data set in Cassandra that was really wide, and Cassandra doesn't do very well at querying on anything that isn't the key. So there was some normalized tables created elsewhere in a different data store that held the 15 or so queryable columns. And so every query could go to that much, much smaller and lighter weight data set to get the key that they needed to go to Cassandra to look up the full row and return all of the data. So something like that, this pattern can work really, really well. Again, your application has multiple calls, one to get the key and one to get the data, but that's considerably quicker than querying on an unindexed column where you're essentially having to scan the entire data set.
Makes complete sense. Excellent. Great. Well, thank you, Steph. Thank you for joining today and talking through both of these patterns. And I guess for anyone listening in, you've seen everything that we've been talking through and walking through here is on the Azure Architecture Center. So do go and take a look at those, because they're all there. They're all available and very well documented for you to go and take a look at. So all there is to say then is once again a big thank you to Steph there for joining in and talking about those patterns with us today. We have got some more sessions coming up over the coming weeks. Hopefully we'll have some of these video and technical issues sorted by then, so you'll be able to see us all again moving forwards, and we'll have Steph coming back in a few weeks' time as well to talk about some more data focused patterns as well. You know the deal. If you like the content, if you have enjoyed what we're doing and you'd like the series, please do let other people know, because the more that we can reach other people with this, the more it encourages us to keep going with this and building even more similar content. And if you have particular areas you want us to focus on, get in touch, let us know, whether that's on cloudwithchris.com or on the social media channels. Then you can go ahead and help us just put some things on the backlog. So thanks again for tuning in, and we will see you next time. So until then, bye for now.